YouTube launched in 2005 and within a year was bought by Google for over $1.5 billion. For the first few years of the platform, the only way to watch videos was through a keyword search, or by sharing links, or embedding videos on other platforms. After a few years, YouTube introduced the famous recommendation algorithm. Now when you go to the homepage, videos are suggested to you automatically. Every time you watch a video, there's a list of up next videos that autoplay, keeping a continuous stream of videos playing. For the first few years of the recommendation algorithm, clicks was prioritized above all else. That means clicks was the metric the algorithm was attempting to optimize, or in other words, the algorithm was trying to predict what videos you're most likely to click. But watching a video for 2 seconds, or 2 minutes, or 2 hours was recorded as a click all the same, so there tended to be a proliferation of low-quality, clickbait type of material, videos with tantalizing thumbnails that enticed users to click on them, but people turned away very quickly when they realized the videos weren't worth watching. So after a few years, the engineers decided they had to change things. So they revamped the algorithm, they changed the metric from clicks to duration. The idea is that if people watch videos longer, supposedly the video is a higher quality, so you can think of duration as a proxy for quality, and YouTube said this was the reason for their change. But it makes sense from a monetization perspective as well, because also in 2012, another big change happened at YouTube, which was before, only officially approved vetted channels were allowed to play ads during videos and therefore to share in ad revenue. But in 2012, around the same time that the algorithm changed from clicks to duration, YouTube also started allowing all users in all videos to include ads and therefore to share in revenue. And if you think about it, the longer you watch a video, the more ads you see, therefore the more revenue there is. So it makes sense that watch time is the ultimate metric that needs to be optimized. This worked really well. For the next 3 years after 2012, watch time per user increased by 50% after being relatively stagnant leading up to 2012. So it seemed like it was a really good improvement. But things got better. In 2015 was the next big change in the algorithm. That's when Google Brain, the artificial intelligence branch of Google, stepped into YouTube and redesigned their algorithm. The Google Brain engineers used deep learning. This is a fancy branch of artificial intelligence that's somewhat inspired by neural architecture. It uses something called artificial neural networks with many layers. The basic point to understand about deep learning is in previous forms of machine learning, engineers had to be really careful in selecting what features, in other words, what data signals, are fed into the algorithm for it to make its decisions. With deep learning, you can basically toss all the features you want at it, and the algorithm itself will look through those, combine them. It'll build new features out of these previous features that convey the meaningful signal. It'll find the signal in the noise for you, so to speak. One of the downsides is it does a good job of this, but even when it's working well, you tend not to know how it's working well because you don't really have access to the new features that it's created from the old features. They're abstractly and mathematically encoded in the neural network, but you don't really conceptually understand what they're doing. Nonetheless, in 2015, now YouTube has switched over to deep learning, and over the next 3 years, watch time increased by a factor of 20 on the entire platform. So huge, huge, huge success. A lot more people are watching, and each person is watching a lot more YouTube. So how does this deep learning algorithm actually work? What data signals does it rely on? Well, it breaks the problem into 2 steps. In the first step, the algorithm takes the giant ocean of videos, all possible videos that are available on YouTube, and it tries to narrow this down to a small pool of just a few hundred videos that the user at that moment might be interested in watching. It does this by relying on what are called user-specific features. This includes your demographics, so assuming that the user is logged in, otherwise the recommendation algorithm doesn't have access to this, but if you're logged in, it has your age, gender, geographic location, the device, for instance, if you're on a mobile phone versus if you're on a computer. So that information is incorporated. It also uses keyword search history. So if you've recently searched for videos about golf, then your recommended videos are going to likely include some golf videos. And unsurprisingly, it also includes another user-specific set of features is your watch history. So what videos have you watched recently? How long ago did you watch them? How long did you watch them for? Etc. So again, your demographics, the videos that you've watched, and the keyword searches that you've watched. That's the first step, going from all videos on YouTube down to a few hundred. In the next step, the algorithm now wants to rank these few hundred videos so that it can offer the one that it thinks you're most likely to be interested in, then the next most likely, etc. So we're now ranking these few hundred videos. It basically does this by incorporating these the user-specific features that we just talked about, but now it also adds in a large collection of video-specific features. So this includes things like what channel produced the video that it's considering when it's ranking, what other videos are produced by this channel, things like what other users have been watching this video, how long those users have been watching it for, various quantities that have to do with the video itself. So the first step is user-specific features. The second step is user-specific features together with video-specific features. Why did they break it into two steps like this? Well, if you think about it, in the first step, you have an absolutely enormous number of videos that you have to consider. So computationally, it's only feasible to use a relatively small number of features, and that's what they do. In the second step, they've now narrowed it down to a small number of videos, just a few hundred. Therefore, they can afford, because they're using deep learning and there's no harm, there's no risk in overfitting. So now that they have a small number of videos, they might as well throw a large collection of features at it. And that's why they include this big collection of video-specific features. It just gives it more information that the deep learning can draw from. Now, there's a couple interesting concepts that need to be balanced by the algorithm. These are not things that the engineers directly program in. These are just considerations that the deep learning architecture somehow has to grapple with on its own. One of these is the idea of similarity. So if I'm trying to figure out what videos you're going to be interested in watching, most likely I'm going to think of videos that are very similar to the ones you're currently watching. That's what I have a sense of your tastes are. That's what I think you like. But if the algorithm suggests videos that are too similar to the ones you're watching, often the user is going to be bored and lose interest and not watch them. For instance, if the user has watched a few documentaries about World War II history, the algorithm might say, oh, let me suggest some more. But after you've watched a couple documentaries on the topic, you might be done with that and interested in moving on. So the algorithm is going to fail if it recommends videos that are too similar to what you watched. On the other hand, of course, if it recommends videos that are too different than what you've been watching, then there's no reason to assume that it found a topic that you'd actually be interested in. Another balance that it has to deal with implicitly is the idea of freshness. So if a video is already extremely popular, there's a strong signal saying that lots of people are interested in watching it. Therefore, you have a good chance of being interested in watching it. But the algorithm wouldn't be very interesting or useful if all it did was recommend viral videos that already have millions and millions of views that everyone else is already watching. Roughly speaking, you already know what videos are popular and viral that are out there. The algorithm is trying to find new ones that you haven't yet found. In fact, that's a pretty precise statement. The algorithm is really trying to uncover potentially viral videos before they've gone viral and help encourage them to go viral by recommending them to users. So it's really hunting for things that are on the rise, so it really has to predict and anticipate popularity rather than just stepping back and measuring popularity. So this is where things stood until about 2018. Then a paper was released publicly by a team of YouTube engineers, and also there was an academic talk given at a conference that mentioned using YouTube recommendations based on another form of machine learning called reinforcement learning. We actually don't know if YouTube started incorporating reinforcement learning at the time. We don't even know if they're using it presently, but the suggestions really seem to be that this was the engineers at YouTube saying, hey, we found this method, it works well, and we're incorporating it. So what I'm about to say, we don't know for sure is going on behind the scenes, but it seems likely. Okay, what's reinforcement learning? If you've heard of it at all, you've probably heard about it in the news because it's the machine learning that powers a lot of successes in games. The best chess algorithm that can beat the world chess champion is powered by reinforcement learning. Same thing for Go. Same thing for computer games, StarCraft and Dota, and even old Atari games. People love coming up with machine learning algorithms that learn how to play board games or computer games that can beat the games or even beat the world's best humans. Every one of these is based on reinforcement learning, which is essentially the idea of rather than teaching the algorithm how to play the game, you simply simulate the game and let the computer play it over and over and develop its own strategies. And you have to give it a reward function so that it knows when it's doing a good job. For instance, in chess, you can come up with some way of measuring the shape of the board and how advanced the position is for one player, and you can count the pieces that have been sacrificed, the pieces that are available on the table, come up with a score of basically how well the algorithm is doing at a given time. In a computer game, often it's simpler. You just measure how far into the level or how many points you've accumulated. So what reinforcement learning does is you have this score that you're trying to improve, and the algorithm just tries everything it can think of until it improves the score. And by doing this thousands or even millions of times, it'll slowly, sort of in essence, evolve a better strategy to get higher scores. Okay, so reinforcement learning is in the news a lot for games. We keep hearing about it, recording amazing achievements and beating the world's best players at this or that. But what does games and winning games have to do with YouTube? Well, what this paper that came out in 2018 or 19 was saying was we can use reinforcement learning in YouTube. Essentially, you view the YouTube user as your adversary, and your challenge is to keep them watching YouTube as long as possible. So the score now in this game is the watch time. The algorithm loses if the user stops watching videos, and the algorithm wins if it keeps the user sucked in. The net result, although we don't know the details from the paper, but the net result, or at least the philosophy behind using reinforcement learning, is now the algorithm can actually try to strategize personalized long-term strategies for each user to try to suck them in. So for instance, it might do things like show you a slightly shorter video in the short run that leads you to a new topic that gets you interested in what's going on in a new area, and then it can play longer videos. So it's not just looking one step ahead to say what's the most likely video that you'll watch for a long time, as the older form did. Now it's looking long-term, like a game of chess. It's thinking many, many moves ahead of how it can, in essence, trick you into watching more YouTube. Okay, so it's a little bit scary, it's a little bit weird, but it is what it is. It makes sense that if you want to increase watch time, you have to think long-term, not just short-term. And that's, we believe, what the algorithm is currently doing based on a deep learning architecture that involves reinforcement learning.